Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Continuation of May, June 2023 question paper. So we're going to deal with question 4. It is divided into 4.1 as well as 4.2. Different functions. Now, given the function p of x is equal to 1 divided by 3 to the power of x, this is an exponential function, right? Remember, I say if the value of a, let's say this is a here, right? If the value of a is between 0 and 1, we have a what? We have a decreasing function. If the value of a is greater than 1, we have a what? We have an increasing function. So, alright, that's all. But if I know if I have plus q, this is my asymptote. This is my what? My asymptote. Let's assign that. Alright. Now, 4.1.1 is p an increasing or decreasing function. Now let's check. 1 over 3 is between this interval, right? You all agree. So we're gonna say it is decreasing. Decreasing because it lies in the interval 0 and 1. Determine p of p, actually determine the inverse of p in the form of y, right? So how do we find the inverse? Remember, I said you just say y it is equal to log of whatever this is here, of whatever that you have here, which is what? 1 over 3 to the power of x. You can also say, alright, let's interchange x and y. You can say y it is equal to 1 over 3 to the power of x, then interchange x and y, then y it is equal to, when you drop this, you should drop this legally. So it means you should add a visa, then what? 1 divided by 3 to the power of x. So answer only is also what? Also 2 marks. Alright? Yes. Then write down the domain of p inverse. Now I want you to take note of this. If the domain of my function and the range of my function, now this is equal to the range of my inverse, this is equal to the domain of my inverse. I'm gonna explain why. Check. If I'm having a function like this, like this maybe, an increasing function like this, an exponential function. So let's say this is f, and then we draw its inverse. Its inverse is going to be an increasing function also. So I want us to collect, I'm done here. Let's collect, or let's say assign this as the inverse. Now let's find the domain of f. What is the domain of f? The domain of f is x is an element of real numbers. Why? It's because it is from negative infinity to infinity, right? Yes. Then what about the range? The range of f. The range of f will be from remember here it is y it is equal to 0, right? So it is gonna, this is your asymptote. Y it is equal to 0, it is your asymptote. Why? It is because plus 0 here, right? So it's gonna be everything above 0. So we're gonna say from 0 to infinity. From 0 here up to infinity. This 0 is not included. Why? Because it is an asymptote. Let's look at the domain of the inverse. What about the domain of the inverse? The domain of the inverse, where does our inverse start? Can you check? Sorry. From here. From here. What happens? Our graph does not exist. Okay. Why? Because this is an asymptote, but it starts to exist when x is greater than 0. So we're gonna say from 0 to infinity, but you do not include 0. Why? Because it does not touch here. Okay. Yes. Then what is the range of the inverse? The range of the inverse, oh, I'm forgetting to say y is an element of Right, you'll just place it. All right, I'll just write it, but remember it is y is an element of the. Therefore, range of the inverse. What is the range of the inverse? Can you check from the bottom? It is the negative infinity. Then it goes up to what? To positive infinity. To positive infinity there. So we're gonna say y is an element of real numbers. Now, as I said the domain of f, it is equal to the range of f. Is it true? Yes, the domain of f, it is equal to the range of the inverse. That is true. Okay, so whatever this is here, real numbers, when you come to the domain of the inverse, you just change it. Here, let's confirm it. The range of f, it is the domain of the inverse. Indeed, you just change y to x, then you are done. Take note of this. Right, these are very important. I'm erasing this. All right, now they say to us, now let's look at this function. It is like this, right? It is a decreasing function like this, y, x. It is a decreasing function like this, okay? But I know that its domain of P, it is x is an element of real numbers. Range of P, it is y is an element of 0 to infinity. Now, the question wants now the domain of the inverse. The domain of the inverse, I know that the domain of the inverse, it is equal to the what? The range. The range of the what? Of the original function. So which is what? The range of this, it is y is an element of real numbers, but now they want the domain, so it means we're gonna just change and say x is an element of, or from 0 to infinite. Or you can just draw here a function for the inverse. It will be like this. Then can you see this from 0 to infinity, the domain there? Yes. Then now write down the equation of the asymptote of p of x blah 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 minus 5. So what is p of x? P of x, it is 1 divided by 3 to the power of x minus 5. So what is the asymptote? The asymptote, it is y, it is equal to negative 5. We are done. This is your asymptote. Remember, I did mention there. So we are done with question 4. We are done with question 4. You'll just say y it is equal to negative 5. Let's go to a hyperbole shape, or for now we can call it hyperbolic for now. All right, given this one, f of x is equal to 4 divided by x minus 1 plus 2. Now, first thing first, I'm gonna say the value of a is greater than 0, therefore I'll draw in quadrant 1 and 3 if I'm required to draw. My asymptote, I know the first one is gonna be x minus 1, it is equal to 0, x it is equal to 1, and the second one, y it is equal to what? Y it is equal to 2. These are my asymptotes. Right? Then yeah. Remember, when they want the axis of symmetry, equation of axis of symmetry, just take this. If they want with the positive one, you're gonna say x minus 1 plus 2. If they want with the negative one, you just include the negative there. Alright? 4.2.1, write down the equation of the axis of symmetry. Already wrote them. X it is equal to 1 and y it is equal to 2. Calculate the x-intercept of f. For x-intercept, I do what? For x-intercept, I let y equal to 0. So it's gonna be 0, it is equal to 4 x minus 1 plus 2. Then I take this 2 to the other side, it is negative 2. It is equal to 4 x minus 1, just divide by 1 and cross multiply. When cross multiply, it is negative 2x minus 1, it is equal to 4. Then divide by negative 2, it's going to be x minus 1, it is equal to negative 2. Therefore, x it is equal to negative 1. All right. Therefore, calculate the x-intercept. The x-intercept, it is at x is equal to -1 in terms of coordinates, -1 and 0. This is how you do your math. You can solve this however, but the answer should be -1. Now they say to us, sketch the graph of f, label all the label all the asymptotes and indicate the intercepts with the axis. Now let's find y-intercept. Let's find the y-intercept. For y-intercept, I'm gonna let x equal to 0, right? So it's gonna be y it is equal to 4, 0 minus 1 plus 2, which is equal to -2. So it means I have what? I have 0 and -2 as my y-intercept. All right. Then now I'm in a position of drawing. All right. Now let's label this as our x and label this as our y. Now the first thing first, let's draw our asymptotes. Where are our asymptotes? X is equal to 1 and y is equal to 2. You can place it here, but what's important is you telling the examiner that this is y it is equal to 2. Or you can just put it here. I prefer it here. Alright, as well as x is equal to 1, somewhere here. The scale does not matter, but you should be you should just indicate to the examiner that these are your asymptotes at y is equal to 2 and x is equal to 1. Then now what? My x-intercept. My intercept with the x is the first one, it is -1 and 0. -1 and 0 somewhere here. I can put it here, -1 and 0. Y-intercept 0, -2. 0, -2, I can put it here. Alright. Then remember I said I'm gonna draw on which two quadrants? Quadrant 1 and 3. So the first one quadrant, it's gonna be here. The first quadrant is gonna be here. Okay, then I label this. This is my f. Then the second one is gonna just be between these two, between these 2 points. Let me just repeat that. Try to make a smooth curve there. Alright, this is also my graph of f. Just label this as -1 and this as -2. Then this is what you are required to do. Now I won't erase this because normally most questions that are following follow based on the graph. Now 4.2.2 says use your graph. You see? Yes. Use your graph to determine the values of x for which 4 divided by x minus 1 is greater or equal to -2. Now equate this to 0. When you equate this to 0, you're going to see it is 4x minus 1 plus 2. It is greater or equal to 0. But what is this? What is this? You know that this is your what? It is your f of x. So it means the examiner is basically saying to you, find where the examiner is basically saying to you, find where f of x it is greater than or equal to 0. So what does greater than or equal to 0 mean? I normally, those who watch my videos under function know that I want where my graph it is above. Right? What do I mean above? Above the y-axis. So above the x-axis rather. So it is this portion above the x-axis, this portion, and this portion. So this is where my graph it is above. So how I'm gonna reason for this one? I'm gonna say from -infinity to -1, and I include -1. Why? Because now I'm told that I should include it. All right. I should also include where it is equal to 0. and at this point -1 it is equal to 0. The other point it is from 1, but look, I'm gonna say from 1 to infinity. The question is, as much as the examiner said I should include it, here I included -1. Here, why am I not including a 1? It is because now 1 it is our asymptote, and then I cannot include asymptote because our graph does not touch. So if I write this in a question paper, I'm gonna say x is an element of -infinity to -1 to -1 included, or from 1 to, or just repeat it as x is an element of 1 to infinity. Someone preferring interval notation can say x it is between -1, and we know that we do not include negative infinity, right? You never include negative infinity or positive infinity. You never include that. Or x is between 1 and an infinite. All right, these are your answers. These were your required answers. Now, 4.2.5 says determine the equation of the axis of symmetry of f of x minus 2, that is a negative gradient. Now, let's first start by seeing what is f of x minus 2. It is going to be equal to 4x minus 1. Where they tell us where we see x, we should minus how much? Minus 2. So we're going to say minus 2. Then plus what? Plus 2. This is just the normal equation, right? Therefore, we get this, it is going to be equal to 4x minus 3 plus 2. Then I'm in a position of getting the gradient. What is the gradient? I take this. How do I take that? I say now, take this portion first. Sorry. I take this portion plus this portion. But now they say with a negative gradient. How do I do that? I'm going to say, I'm answering that question here. I'm going to say y it is equal to negative. All right, they said with a negative gradient. Then I take this one. I take this part first. It is x minus 3, then plus 2. Then you can now solve your mathematics. Negative by negative, it is positive. Then like this. This is your equation. If they said with a positive gradient, you're going to say y it is equal to x minus 1 plus 2, x minus 3 plus 2 only, without the negative. So I believe you are following, and I strongly believe you understood all of question 4. And yeah, let's meet on question 5. Thank you.